They can tell when somebody's blood sugar is really low. So they're diabetic alert dogs. There are dogs that can detect Parkinson's disease, except we don't take that as part of our diagnostics yet.
From their sense of smell.
Just on sense of smell.
Amazing.
You can tell, they can tell different sense of cancers.
Talking to Praful was really fun. It opened my eyes to lots of things I didn't realize. One, that human-animal communication has a very deep history, that there were classified programs with the government back in the 60s, that Google has recently released a new language model for talking to dolphins, and that people have studied animal communication for a long time. I guess I expected this conversation to be purely playful and somewhat silly, a tinkerer trying to figure out how to talk to their dog. But what he's really shown is that you can, in a grounds-up way, train original models, build hardware and software on the client side in the cloud on an iPhone to do new and groundbreaking things. That is the real lesson of this conversation. Two is that this bridge of AI to an animal like a dog could be actually profound and really important for society. Just think about how dogs can sniff out diseases, but we have trouble communicating with them. If we can bridge that gap, it could unlock a lot of positive benefit for society. So I think this is a great conversation. I think you're going to love it. Let's go.
Hello and welcome to an episode of One Shot. This is our global stage where we talk to people who are doing stuff kind of out there and kind of on the edge and moving the field forward, so to speak, and we go under the hood with them. We take a deep dive in what they're working on. I'm super excited because today we're with Praful Mathur, and he's working on getting AI to enable you to communicate with your dog for real. Welcome.
Thank you so much for having me.
This is amazing. You are getting a technology together with AI that will allow you to have conversations with your dog. Is that the idea?
Yeah. So when we talk about communication, a lot of what people think about is, can we have a philosophical conversation with dogs? But usually that's not even the first thing that we talk to about with each other. Very rarely do we have just deep conversations. It takes, quite a bit of effort and relationship building. Yeah. A lot of what we've realized is that dogs have a very key way of understanding us. They understand word boundaries, they understand accents, they understand words. They miss certain consonants in English, very similar to what you would expect with people just learning the language. So you'll see the same kind of patterns within ESL learners or other kind of people just picking up English. But dogs are very good at it. They're much better at understanding spoken language than even the state-of-the-art models that we have today for in the realm of AI. And in some of the stuff, you can tell things like cocktail party problem, identifying in a whole conversation when something is relevant, or how do they disambiguate multiple audio streams in the same room. So, there's been many times I've had parties at my house and I will snap or be very discreet about letting them know not to do something or to stop doing something, and they quickly pick it up, even though that could sound like a plate getting onto the table. And so how do they discern that kind of understanding? Yeah. They have a very good understanding of our eye gaze. They have a good understanding of our finger pointing. So their understanding of our communication is unparalleled from our version of their understanding.
Well, you started with like words and sounds and consonants, but thinking about Pavlov and the Bell response to salivate and these things, like dogs use their own body language to communicate. I think, I'm ready to play. They kind of come back like that. And so it's more, I actually was reading about how communication is well beyond words, like even smell, like leaving a scent, somewhere in the forest is a form of communication, right?
Correct. So, we have a very similar parallel. Like, when you walk by a bakery and you smell bread, it entices us. That's a form of communication we've developed. But our sense of smell is fairly limited compared to what dogs can do. They can tell when somebody's blood sugar is really low. So they're diabetic alert dogs. There are dogs that can detect Parkinson's disease, except we don't take that as part of our diagnostics yet.
From their sense of smell.
Just on sense of smell.
Amazing.
You can tell they can tell different sense of cancers. Now, there's a person that can detect Parkinson's from smell. That's how we know that this is possible.
Well, that's an interesting idea, we'll get into what you're doing, but thinking about the dog as a peripheral to detect things, and that we feed into our AI systems in our world to make our life better. Not just talking to your dog, but your dog's out there like finding danger.
Well, the military already does this.
Right. Like what?
They use it for bomb sniffing dogs. Yeah,
at the airport.
Well, at the airport, but they also have dogs that jump out of planes with the Marines. They have dogs that will, literally jump out of a plane with a person. And to train that into a dog is a lot of effort. But the thing is, dogs are a huge part of our economic system in the United States and globally, right? They help protect us from agricultural damage, from literal threats, from the police. Then there's also a massive amount of social media consumption that's mostly around dogs and cats.
Okay, you mentioned military and you talked about we're already doing this. I was looking into this, and I'm sure many people are aware, but dolphins, right? There were sound translation machines in the 60s developed by the U.S. Navy, and then it became a classified program. It was like, let's talk to dolphins, and they're out there doing missions for us, right? There was a famous parrot, that Alex the gray parrot, I'm sure you're well aware. I didn't know this, but this was a parrot that learned 100 words and could answer questions, and they think was the first non-human to ask a philosophical question, to your original point.
Yeah.
And maybe you could tell us what that was. But the harbor seals that speak English, you saw this is a great video for people who haven't seen it. Maybe we'll cut it in. But the seals are like, hello, how are you?
I've not seen this.
Oh, yeah. There's a seal that this was in 1985 that it was for many years. This one seal, as kind of an anomaly, had picked up words from the trainers and would come up and pop its head up and say, hello, how are you? And you play in his English.
Oh, wow.
Yeah, crazy. And, there's a question of like mimicry and understanding that we don't know. But clearly anyone who has dogs knows they're very interactive and they can learn words. Walk, ball, they can know exactly what those words mean. Now you're doing AI to sort of pull on these threads, right? What exactly do you have today?
Oh yeah, so there's quite a lot. In terms of the stuff you talked about, dolphins, we can go into that as well because that's where I started.
Okay.
But
was that your inspiration? Was sort of those threads that you picked up on, or the historic threads?
Yeah, absolutely. So Dr. Denise Hertzing did a TED Talk, and she's now back in the news because she worked with Google to create Dolphin Gemma.
I saw that. Yeah.
So and that's her team, her and Dr. Stad Thanner. And they're both, very well respected in the field. She actually wrote the book called Dolphin Communication. So,
and this only came out like a month or two ago. That they announced that work and that they have a dolphin LLM.
Correct. Yes.
Yeah. So let's dive into the demo. So you're calling it Sarama. That's the project.
Correct.
And this is can we just see the demo really quick? And just so people tangibly understand what you've built today.
Yeah. So we have a device.
Yeah.
Cool. So this one is just ESP32 plus a battery. Here we have a microphone, Bluetooth, Wi-Fi, and immune a microphone. Okay. And this is used to continuously monitor what's happening with the dogs, identify specific vocal patterns, identify their environment, what they're reacting to. So if there's a doorbell, identifying that. So we just have a large level of continuous data feed from here.
Okay.
But the main processing happens on the app.
So architecture, though, wise, just to continue that thread, this is collection data and streaming it over to an app.
We used to do Bluetooth, but now we do direct Wi-Fi. We found that Bluetooth was just very unreliable, especially on a dog.
Oh, interesting. Why? Just because dogs are roaming around a lot and disconnecting?
They leave. Their fur can get in the way.
Oh, interesting. Really?
Little bits of stuff, right?
So not as resilient as Wi-Fi, just as a transport, as a RF transport.
Yeah, exactly. Also keeping BLE on all the time and then requiring constant connection. If you skip out the connection, then you have to save it. Yeah. Then if you have a large audio stream that's collected, then connect. So Wi-Fi
is the battery consumption on Bluetooth better though?
Yeah, way better. Yeah. So we don't send data in real time anymore.
Okay.
We stream it or we queue it up and then stream it once every 5 minutes.
So the hardware part of this project is pretty intense, I'm sure. So then on the software side, though, once you do all of that and you get all of those hurdles, it's eventually in an iPhone app and there's a cloud, right? What are you doing in those two pieces?
So essentially on the audio side, so so we have the video and then we kind of We made the updates yesterday to the app, so there's certain things not working right now. But anyway, there's a discovery part, which we should have audio here. Yeah. But right now it just shows zeros around. But the main thing is that we collect the audio, we categorize it, and each categorized audio stream allows us to determine, okay, where is it? Now, most things in the beginning go to squirrel, which is our et cetera category. So we have attention, alert, health, emotion, intent, and squirrel. And that allows us to be like, okay, here are all the collected audio streams. Here's the vocalizations. What are they each meaning to the person?
Okay, cool. So you're doing a bunch on the app there to allow obviously the user to interact or see what's going on.
Correct. Yeah. So we have a diary. It's not pulling up the last couple of days, but essentially we have like the videos we've taken. The summary should just be something like, hey, Cash might have experienced something unsettling or exciting that led to his agitated barks. To improve, try engaging Cash in some calm activities.
Are you also signaling off the ambient noise like the car horn or the doorbell and these kinds of things, or not?
Yes, we do. This is a little bit of a balance because we try to ensure, or right now there's a hole in this because I needed to, I didn't have the translucent filament, but the thing is it should be completely covered so that we're not collecting conversations that people are having with each other, because that becomes a part of issue. Yeah. But so we only want to capture audio that's very loud or close to the dog. Okay. So if there's a vibration around the dog, there's a bark. So we can collect certain things like doorbells. We can collect things like skateboards sometimes. But if they're too distant, then they get filtered out by the device.
Okay. So focus those on the dog vocalization and translating those things.
Correct.
What are the kinds of things you would see if you got home and your dog had an adventure that day?
So a lot of what we find out is, especially when we've left them alone, is if we find like poses where they're jumping, we know that they've been on the bed or the couch, which they're not allowed to be on. If there is like, especially if jumping and they're lying down for quite a bit of time, if they are running around while we're gone, that's usually when they see the cats in the yard, so they're running up and down the stairs, or they're running up onto the couch.
But I don't think of running as conversation. You know, the promise of like talk to your dog. I'm thinking of conversation with me with the dog in the moment. Like, talk about that for a second.
Right. So a lot of that is going to, so there's a difference between understanding from vocal behavior, like emotions, right? So are they, we were talking about earlier, when my dog barks to some other dog in the window, that was all playful. So it turned out that was mostly leash kind of anxiety, where my dog's on a leash, their dog is behind a window. They're both agitated. They can't get to each other.
Right. They're basically saying, I'd like to go play. Let me out of here. Let's go. And who are you? But it was not angrily like barking away some threat.
Yeah,
you were able to tell that.
The AI was. I was not able to.
Okay.
I thought it was agitated or upset, and it just didn't like.
How does the AI do that? And what is your are you training an original model? And where do you get the data, or how are you approaching this?
Yeah, so we had an academic data set we trained it on, and then we expanded the data set with our own, where we have veterinary technicians look at the data and annotate it.
Okay, so like a dog whisperer is there to be the source of truth about what's actually happening here. How's the dog
for like emotions. Now, the thing that's very interesting is that sometimes those annotators are wrong, and so video ends up becoming a really good test of whether or not they're right or wrong.
Interesting.
So you can disambiguate this because video gives you a lot more data, so you can annotate the video first and then separate the audio and then see which annotators are very good and then operate that way.
How universal is this data? I mean, you mentioned already that dogs vocalize differently in different breeds or different scenarios and environmentally. Like, I'm thinking about my dog. My dog has this piercing bark that's just horrible, but only when it's time to play with the ball and you're not playing. It's his, I guess, frustration that like, come on now, But if you heard that bark, if you heard the audio track of that bark alone and you were just a human, wasn't trained, you would think that dog is pissed, is stressed out or being attacked or something like. But how he, whether or not that's, you can detect or you can label the data as being the right emotion, that same sound might for a different dog mean a different emotion, right? How do you account for that in this? You've got a pretty interesting problem, right? This is not. training like corporate data sets on, things where we understand English and we can, how do you get data for this that's accurate? I mean, you mentioned the trainers, but I'm just thinking like feels like a very big problem with a lot of complexity.
Yeah, so there is quite a bit of nuance, right? So certain things about certain emotions do end up being more universal because of certain features that work well. But there are certain times, and we found this, which is why we've had to annotate a new data set for this specific purpose, is that data that, so like a German Shepherd barking ended up coming across as upset very frequently because of the loudness of the bark, and that's how it was trained. So when we updated that data set, we found that it ended up finding different features to anchor on, right? The other thing that we found is that emotion ends up being more universal than people think. And a lot of it is that even if you miscalculate the emotion briefly, that over time, when you look at the bark sequence over a long period of time, you do get a very consistent record, right? So you might get playful, upset, playful. And there also is a transition from playful to upset, like you were talking about. There is a frustration, but it's more of a playful frustration rather than, hey, like I'm in attack or I'm in danger or there's an agitation that someone's at the door or there's like a mailman coming to the door. Actually, even the mailman we found is a lot more playfulness than it is actual agitation.
So the input is basically audio with annotations. Annotations can be gotten from trainers or experts. I would imagine other things like the visual you mentioned before.
Correct.
You can see a dog's in a playful stance, so that bark's got to be playful in nature, right? Are there other things you've looked at? Like I'm wondering, the inference just needs the audio and the model, but when you're collecting data, you need to label it. So how do you label animal data? Like temperature of body? Can you look at different factors like that?
So we are going to add more and more sensors. Initially, we hesitated because there weren't a very large multimodal models, and those are starting to emerge, right? Yeah. Facebook had released one through their AI research called Language Bind in 2022, but that hasn't really evolved very much. There is another model by Peking University and Alibaba, I think, that's called Image Bind, or maybe I may have mixed those two up. But the point is that they take multiple modalities and they embed it into a shared embedding space. The challenge with a lot of that is they're still new, right? And so we now want to take into account heart rate, temperature, audio, video. But the thing is that you can do a lot with just video and audio, and you don't need to go very, very deep with all of these other sensors. Now, when you want to find things that are non-obvious or when everybody is wrong and you want to figure out if you're right, but I still think that there's a lot that we have not explored in the existing data sets that we could get very deep with. And so this is sort of the kind of challenge when people are first building language models. They're like, so much of communication is nonverbal or non-language based. There's emotion, there's body language, there is the way that somebody frowns when they say something. Like, how can you determine sarcasm? It turns out even with just written text, we can determine sarcasm. We can determine when something's funny, we can determine when something is serious, and it's because of the context that surrounds it. So a lot of our analysis has not been on the pure signals coming in. It's about identifying what context is that signal being placed in.
How far along are you in terms of getting a pretty good, how do you think about the confidence interval? How much data and training do you need to get a pretty good representation of this bark means, hello, I miss you? Or whatever it is, whatever granularity that is. How much data do you need to get a good confidence across breeds and scenarios and environmental kind of factors? Yeah,
so going back to your question, like how can you talk to your dog, right? So first is about getting emotion and getting that set of things in a good place that we feel confident in. Yep. Then the next question is, can we determine, okay, once we have an emotional criteria down, can we then determine what's the context that this bark is in? So that context is what we're now building a lot more models around. We have a fairly high degree of confidence depending on what the context is. But the question now we have to explore is getting more data. So that's part of the reason why I'm very much interested in exposing what we're doing more broadly to the public. So that way, as we release our product, as we release our applications, people look at it and say, okay, I can contribute here. This is the thing I'm interested in doing. And it's very much like the ethos. So we're going to be open sourcing our hardware. We're going to be open sourcing our firmware that goes on the hardware. We'll be open sourcing some of our very, very early models that we experimented with. But the main question is about, okay, now that we have this level of understanding, can we work with the community to do more around training?
Let's switch gears a little bit and talk about like under the hood, the ML stack in particular. And maybe you could just explain high level, like just that piece of it. Like, what are you training on? How does that work? What are the steps? You know, if someone wanted to do something similar but in a totally different area, what would they do?
Yeah, so okay, I mean, I would like to see someone do this with cats. So with dogs, the big thing was okay. First, we did a very basic analysis on video. So could we find their points, body points, and there's like a few models out there, Deep Cut and there's a few others I can't remember on the top of my head. And that worked well enough, but there's problems with it. So you get that, and then you go, okay, I have video. Now can we understand this video only? So it's what we started. Then we started to collect audio data from people. So a lot of the first customers or first users we had very vocal dogs. So they record them and we'd ask them to annotate it themselves. Okay. Then we took their annotation and their audio and we'd send it to professional annotators to see whether they were consistent. Now that was with the people who ended up performing very high, then we kept their annotations.
But from day one, you were basically getting gather data, either extract from somewhere like video or gather it. And you're building a model, you're training a model from scratch.
Yes. So we train most of our models on classical approaches, pre-transformer models, because they're much easier to debug.
What approaches?
So there are scalar vector machines or SVMs, and then there are just KNNs that are very, very easy. Okay. That's how we started, and now we're moving towards transformer models as we get more data, as we get more annotation. Because for transformer models to be very effective, you just need very large data sets. Right. It's hard to do something on smaller data sets. And with that in mind, it's also hard to do stuff. It's also hard to scale up these classical models. So it's kind of like as one approach starts to degrade, you have upgrade path.
At this point, how much data if you were sitting to train?
Oh, that's a doorbell.
Oh, okay. So what did your dog just say?
She's like, it was at the door.
Well, that's just a Pavlovian.
That one's more trigger.
Yeah, a trigger thing.
Yeah.
Interesting.
So I should have had the app open.
Oh, your doorbell at home went off, and she recognized that as somebody's here, right?
Yeah. So our doorbell is on my phone, so that's the whole thing. Okay. What was your question?
Question like at this point, how much data do you have that you're training on?
So we have tens of thousands of bark sequences. We want to, or actually, sorry, it's over 100,000 now, because. I have this like train thing that I used to do tens of thousands, and now it's over 100,000. Yeah. It's these bark sequences, and many of them have been annotated by people. And so we've trained on that. Now we need to get to about a couple million for it to be useful in a transformer model. We're starting with very, very small parameter transformer models and then going into larger and larger transformers.
Got it. Yeah. Okay, so to bridge that gap, you're getting the device, you're open sourcing it, you're getting more data collection, and then you'll continue to work on this and it'll get better.
Correct. Yes.
Okay, very cool. What about like going to you sort of seemed like you started with extraction. Did you go to YouTube and just figure out dog videos that you could?
We tried that, and at the time it was not very reliable. Maybe now with these newer approaches it can be.
In what sense reliable?
Well, you have audio collected from random places. You don't have a consistent source for the audio. Okay. You don't have a consistent source for the video. Some of these have audio where a dog is behind a chain link fence. Sometimes it's like in a yard. Sometimes it's in a field. The other thing is that the thing that the people wrote was happening with the dog may not actually be the right thing, because these are videos that are taken from Instagram and reposted. And
right, you might have to rewatch the videos and relabel with a professional or something.
Yeah, exactly. And then there's like music in the background. So then there's a lot of like data that you can't really use.
So it sounds like you decided that, well, there's a pool of data there. It's the cleanup job it's just too messy.
Yeah, we tried. We spend a lot of time like, okay, can we extract the audio? Sure. Can we remove there's like source separation technology. Sure. But it's just like, is this worth it when you could
Right.
just go to people with dogs and
Yeah.
many people are willing to give you mass amounts of data?
Yeah. Okay, that makes sense. Okay, so we went through the hardware piece, we went through the app piece, and we went through the training piece. What other pieces are there?
I mean, the big thing is understanding, to your point before, like each individual dog's relationship with the person is important to this system, because what you said is like, okay, your dog's piercing bark means that they want to play with the ball and you've not played with them, right? With that same bark in another dog could mean, hey, like I'm in pain, I need some help, right? How do you disambiguate that kind of stuff? So that's why we started with emotion. We started with context, and I'll just I don't know how to stop, because this is one of those little notifications that is like urgent, and you can't like disable it. Getting that context is very key, right?
Yeah.
So figuring that part out is something that we spent a lot of time working on. And what we found is that we're now more and more consistent with what people are expecting, but it requires a little bit of calibration with the dog and the person to get a good setting and understanding.
Can we do something? Does your dog vocalize? Can you get her in a scenario where we could see the app in real time respond in a way that shows the app inference side working? Okay.
Yes.
Awesome.
I'm going to open up Xcode because okay. So this is just new because I knew I was going to do this podcast. I wanted to get it in the app. So it's going to be in the logs right now, but in the next version, we're going to be able to just play it out.
Nice. And what are we going to be looking at? We're doing inference, but you're doing it on your computer because it's not in the app yet.
Yeah, so I'll play it. It'll be on the camera side, and then we should get something.
Oh, and then you're going to stream it and run it on the computer, so we'll see it in the logs. And that's just because hooked up to a newer model or something version? Or
it's hooked up to a new model, and I haven't just been able to display it on the screen yet. That was what I was working on before.
Okay, got it. Okay, and it's going to tell us what? I guess we'll see.
All right, cool. So first thing is just to detect the dog, put her in frame. Okay. All right, so this is just a basic model, and this was actually just using ChatGPT. I'm not actually doing anything special here. It's mostly when she barks that I do the analysis. Oh, you can't see it, right?
There we go. Sorry, when you said ChatGPT, you mean what? Like a vision model?
Visual. We just did something very straightforward so that people could get something before we.
Oh, that.
This is what I have to hook into our new models, right?
Got it. Yeah.
So this is just using ChatGPT. All right, cool.
Okay.
So Kai, speak. All right. So here's where we see it.
Okay.
Okay. Yeah. So it just says that she wants to go out, play, or go out, right? So there's a 51% confidence she wants to play. And the reason is we taught her speak with a ball. So it's a play bark that we used.
Okay.
Okay, so
that's funny because I would think that if you're training for speak, it would normally be just like I want the food.
Yeah, so there's two ways to do it. You could pull away the treat or food and
give a reward.
And that was a reward.
Yeah.
But we used the ball.
The ball is rewarded. Going to play is the reward. As she's learned that's the way. Does she come to you randomly to bark like that when she wants to play? Okay.
Yes. Not only will she do that, she does it very often. So when
what's her vocabulary through this app? Like how many words or expressions or emotions do you?
So in the discovery mode, I have 30 or so vocal patterns of hers that I've categorized, but we'll get to about a couple hundred at the end of this year. Okay. The irony.
What are the 30? Just give us an idea. What?
So health alerts. So when she was whimpering, when she had the foxtail, that was when I was able to get that alert when there's. This is happening whenever the doorbell rings, or when somebody's outside, or when like there's a delivery person. She can recognize a delivery person about 10 feet before they approach our door. I don't understand exactly how that mechanism works. Delivery drivers can be at their neighbor's house too.
Sure.
But there's a specific way that they walk to our house that she gets it.
She'll hear that and start to vocalize something, and you'll register that through this app as what's coming out of the words here.
Mostly the emotion is agitated, playful, but then the doorbell rings 30 seconds later or 10 seconds later.
Interesting.
And then when the doorbell rings, then she runs downstairs, and then that's more playful.
Yeah. Interesting.
Then there is there's only like 2 or 3 intent barks. The intent barks are go out, play, and food. But she's actually stopped vocalizing food as much. A lot of the reasons I've collected only 30 is because I took it for granted that I'd be able to get the barks.
Yeah.
Turns out that it's better to collect as much as you can, which is why the device being newer is much more important. So
let's talk about play versus food, that bark. For you not having run it through the system, could you tell those 2 barks apart?
No, I mean, I think I can, but when I actually ran it through the system, I was wrong more often than I was right.
Okay. And then when you run through the system, it's consistently right. And you know that because of what comes next. You observe the other hunger signals or whatever it is in her behavior.
Through the system, I mean, it's like 80 to 90% accurate, so there's still some inaccuracies. Yeah. But the reason why I have more confidence in it is because the next thing I do is much more actionable. So historically, it's like, okay, you just ate, you just went outside, you just played. What can this be?
Yeah.
And so this is very important when she had that health issue with this foxtail, because she kept like, obviously she was licking herself, so that was obvious. But the fact that she was just agitated a lot, and then every day her movement went down, and at one point she was limping. Then that's obvious, right?
Yeah.
But
but in retrospect, you could have picked it up a lot sooner that she had a health problem.
Yeah, I mean, the
AI knew.
The system was telling me. I just was like, oh, something's wrong with this. So I just kind of updated the model, which is backwards from what I should have been doing. I don't know. I mean, I'm curious to hear from other people. Like when you're training models, how much confidence are you putting into these things? Because it is very hard for me to believe that this is working as well as it does.
Yeah.
Because it's a very simple, basic kind of analysis.
Mm-hmm. Well, you say simple, but I mean, I think anyone you're mixing hardware, which of course has electronics, embedded software, ergonomics, bill of materials and manufacturing and all the design stuff, right, that comes with it. That's before you even get to the software side, which itself even then has a mobile app. It has an AI training component, a cloud deployment and production. Like there's a lot here to take on. Like to talk to your dog, I guess it's worth it.
Well, so this is something that I'm very excited about, is now people can be much more ambitious with these agent frameworks than ever before. So I actually started all of this as a interesting thing in 2019. And I didn't get serious about it until later in the pandemic. In 2019, 2020 was more of like a way to like talk to friends and be like, oh, this is some cool stuff happening.
How are you using AI in the meta process? Like earlier we were talking about design iterations, right? So there's writing code, but the stuff around that, like deciding what to do next as a company, or deciding within the space that you're exploring, which directions are most or not technically feasible. Do you use the AI in these kind of ways?
Not for technical feasibility, because we found that for things that are outside of its domain, now they're getting very good. I mean, don't get me wrong, but like it'll end up veering you into very weird paths. But if you can narrow it down to say, hey, these are the constraints of the company. This is what we believe in. Here's where we want to go. How would you organize our work? We found it's pretty good there. So this Sunday, I was trying to do a weekly plan. I asked ChatGPT to put something together. I asked Claude to do something. Then I took the difference and I figured out, okay, these are actually fairly good insights. I actually had it critique our company as an investor.
Sure.
It gave me a pretty good reason why this is a hard investment or an easy investment, which investors would work well here, especially as we go out for our seed raise, like what is going to be good to show. The other one I found it's really good at is generating concepts. So for example, I can show you, we're coming up with a new product on Slack. We have so here, like we can just I told it to give me Hermes style something. It just put Hermes there, but it's like, okay, what should the den look like? How should this be set up? what does the collar look like when you have a light to show you emotion?
Oh, that's cool.
And so now I can very quickly experiment, show it to people, get feedback, reiterate. And this would require historically an industrial designer, a designer, a person who has an understanding of how to use Photoshop effectively. Yeah. Sometimes they're one person, sometimes they're not. And now we could do it in like 10 minutes.
Yeah, cool. I love this use of AI, the stuff around the core of the company that, again, it's like you already have so many domains to deal with between embedded and industrial design and software and iOS and cloud and ML. It's like now you got to do all the other company building stuff so you can really scale a small team. As you mentioned, like industrial design itself is a whole domain. Yeah. I wonder, on the open source strategy, have you had conversations there? Like you have this goal, you want to go from 100,000 data points to millions. And of course, you're going to do that by open sourcing it and crowdsourcing from your early users. But how are you going to incentivize them to give you the data in the right way and to create the labels? And what is the overall user experience of that as a system? That high level problem is an interesting one, right?
Yeah. So, and this is actually one of the things that, I did breakfast this morning, I was telling my friends to do, and I heard it all the time, launch all early and often. And I made the mistake of not doing that here, right? We launched a lot in 22 and 23, and then 24, we kind of just like, hey, do we know what we're doing here? And this year, we brought on a person who's very good at product. She understands design incredibly well. So we've decided she's very good at experimentation, and that kind of framework is needed for consumer. Yeah. So I think that that's been the thing that we're working on. But what we found is it's not hard for people to give data here because people are very generally interested, right? Yeah. The part that we found historically that was really complicated was how do we take the improvements we've made, because some of them are regressive, things get worse, and some of them are very improved things. How do you communicate that back to people where they're like, hey, the thing that I did yesterday that was working is now broken. How do I trust that the thing that you fixed is actually working?
What is an example of that, a regression?
When you update a new model. So one time, what ended up happening is we added, I was talking about the German Shepherd data set, and it took dogs that were previously agitated and made them playful. So we had to then correct
that
for
could be really
that.
Confusing.
Yes.
Yeah, if it's getting it wrong, obviously.
Especially when your data set's small.
Yeah.
And your data set's small and you add more data to it, it could shift the whole inference.
Yeah, that makes sense. It's interesting to see these industrial design concepts of like, how do you visualize, how do you get the sensing that you're doing on the dog to communicate in a way that's more readily understood by the human? Because I'm not running inference on the bark here in my head. You're running it here, and now you can give it to me in a red light, green light, yellow light kind of way or something. What are those other ways that you can communicate back? And obviously translating to English, putting it in the app feed, that's one. Have you thought about other ways?
Yeah, so...
and why not just vocalize it with a text-to-speech model?
Yeah, so that is the one we get often.
I'm sure.
So this is what I thought everyone would want. Yeah. And there was a collar from Up. That's what I was initially building. Yeah. And the number of people who said, like, my dog will freak out if there's a speaker on its neck is very high. But we've now found a very small contingent of people who are like, I want a speaker on this. I want to see what's happening. Yeah. Because the speaker ends up giving reinforcement to the dog. So as they bark and they hear something, they now know what word they're communicating to the person.
Oh, really?
And so,
interesting. Yeah, that reminds me of the dogs pushing the buttons.
Yes, exactly.
Letting them command the communication device, basically.
Exactly.
Interesting. I find the cognitive load of doing that is pretty high. Do you do things with... So you're branching, obviously, and you're queuing up. Do you have to do something like with giving it a work plan or to-do list that it's checking off? What are those things you've learned that work really well there?
I found that it's the narrower, the better. And the way that I've maintained the cognitive ability is that we'll first make sure that it's on the right path with the first set of work plans it does. Then instead of giving it a really large script, I will just queue up a bunch of things I needed to do endlessly. So that way, because you can now do that in Claude Code. Right. And so it can create checklists for the first thing. And if I think it's on the right path and I do it, then check in. It is a lot of work because you're like just tabbing through stuff. What I've realized is that even though I've wanted to do these simultaneously, I end up working on one feature at a time, but
Yeah.
they're all narrow. That when I finish it, I move on. But it reduces my ADD stuff because now I'm already halfway into a problem. It's my like obsession to solve it. So I have 5 things. By the end of the day, I solve 3 or 4 of them. The last thing I do is look at the 5th thing, keep it for the next day, figure out what should push, figure out what I could keep,
Sure.
and then
Kind of have it summarize and dump off. You can unpack it later and have it continue on if you're not ready at the moment to cinch it off.
yeah, I just do it very narrow stuff. So it's
Yeah.
either done or it's not. And
Yeah.
if it's not done, then I just do, it's 1 or 2 other iterations, and then I
Yeah.
finish it.
There seems to be a trade there, though, because I've noticed with the ambitious enough but narrow, you spend a lot of time just waiting and then reviewing. And it's very boring work, and it's very tedious. So then you want to spin up several, but then you have this cognitive switching thing that's a tax, right? So it almost makes me think like maybe I should spend a lot of time up front, right? And then just let it autonomously go for a long time on its own. And then a lot of time on sort of like acceptance testing or something. And then if I could spin up, if there was a way to do that, but then spin up 5 of them, slightly, have it give some leeway. You be more ambitious, you be more this, you be more creative. And then I wake up in the morning and I can just do a bake-off.
So I've tried this. I've tried to do like a very involved prompt, and I ended up finding it gave me worse outcomes because it ended up misconstruing one of my sentences, and it was very hard for me to then like change whatever that context was because it was such a large window. Now I know some people have been very successful at it, at least online they say they have been, but I've never met anyone in person who's done this effectively. What I found is like very narrow, small changes, but where it ends up becoming very useful is if I have very narrow, small things, but the first couple of iterations have been wrong, and I have to undo it. So I can say deep think, and that usually takes about 3 to 5 minutes to usually get something done, and then I can spin up another one. So
when you say undo it, you mean you literally are tracking progress to a point. I'm happy from here. Let it go forward, and you're just doing a revert.
Even more granular in the beginning. So I have a window open and I have Claude Code open. Then I will look at the changes coming in, then stage them when I'm feeling happy with it, and then if it's going off course, then I will stop it and then undo the unstaged changes.
Okay.
So I'm using Git very, very closely.
Interesting. That's great.
But I don't watch it so much that I'm like watching every real-time change. I'm mostly watching to make sure it's not off course. I have tried to do it where I have 5 tabs open and I go back and forth, but to your point, it's like you're at one point I got confused on what I was doing in each one, and then I had to like make notes on every, like I literally had a note, like the Mac OS note, like this is what's happening here. And then I was like, what am I doing here? I could just focus on one thing, but I would like to make that work.
Yeah, that overhead is a lot. And I've noticed one fail pattern for sure is like if it did veer off somewhere, it's better to revert and just do it again than to try to prompt it back into shape. Oh, sorry. Could you prompt your way to a refactor to do it more over here? Because, 80% done, but it's wrong. So we need to, that I've gone off. Yeah, it's been terrible. I've had really bad results and wasted a lot of time on that.
Well, where I came up with where I staged things that were good enough is when I had an issue where I had mostly everything done. There was one thing that I had to reposition. So I asked it to reposition it. This is in Windsurf. It undid like 3 hours of work. It took me 6 hours to get back to where I first got to. And I couldn't undo the work in Windsurf because I made manual changes. And the way that the revert works is not.
That's right.
And so that was the most frustrating thing I've ever had. And it was so frustrating because they got it done. I ended up getting to the same place, but it was slightly worse. And that was when I was like, man, sometimes I should just do the changes myself. Because that position change must have been like 2 seconds with a person. But I was like, I'm already in flow. I might as well do it.
Sounds like you're pretty deep in with pushing the boundaries on agentic coding. I'm curious on the model side, have you had much time to play with Gemini 2.5 Pro versus Claude 3.7 or try to figure out like is one better than the other? Some people are very opinionated on this. Some people are doing a lot of testing, and some people have found, this is for this case, and they're very sophisticated about what they're using for which. I'm curious what you've done on that front.
This is like very interesting because I can't tell you what works better in different models, but I have a feel for it.
Yeah.
I don't know why that makes sense.
What is that feel?
So what'll happen is like after a certain period of time on windsurf or something, I'll just instinctively switch to 2.5 Pro or go from 2.5 Pro to Gemini, to Sonnet 3.7. And what I found that like works well is like when I'm in flow, it's kind of like I can change these models and I continue to get some outcome. But generally the main heuristic I have is when things don't work, change it and then try it again. Change a context window, clear it. But I've had a lot of success with Claude Code recently, so I've continued to use them a lot. I've had some success with Plandex and some with CodeBuff as well. But the thing is that more than the context of changing between branches is a context between these tools because they have different models of how they work. Like,
of course,
even though they're using the same underlying base model, like they do things very differently.
Sure.
So I've now started experimenting with Rue a little bit, and
it's like how their system prompt is set up will imply a different workflow for you.
Well, even the way the workflows work, like Plandex does a shadow Git thing, so it doesn't commit to Git. Initially, it uses some shadow stuff.
Have you tried Codex?
Yes, when I first released, it wasn't good, and then I have not tried it again. Have you?
I'm the same. Yeah, it was immature.
Yeah,
it had some basic features that just sort of must have.
Yeah, I mean, okay, so to be honest, like there's so many of these things that come out, and the first weekend, like all these came out. I think it was like 2 months ago, like a bunch dropped like one after another. So I spent like more time testing these models and working on the company. And I was like, this is a waste of my time.
Except when it's not.
When it's not, yeah. And then you're like, oh, this is a huge benefit. So
well, we should wrap up here pretty soon. I'm just curious, how did you find out about AI tinkerers? And we already asked what you're tinkering on, but I'm curious how you've discovered it.
I found some video on Twitter where somebody was demoing something, or maybe it was your post about a bunch of people demoing stuff.
Oh, cool.
I was like, oh, these people are doing really interesting work. And then I found out about that it was in SF. I think that was a Seattle one. And then I met Conrad, who had done like a like AI vision thing with his dog.
Oh, yeah.
And then I reached out to him and I was like, oh, what do you think of Tinkerers? And he's like, it's awesome. Like people are so chill. Like you go there, you demo stuff. And instead of like the feedback being critical of like what didn't work, it's a lot more of like, here's what I've tried. Have you seen this? Or awesome. Have you used this approach instead? And it's more productive.
Yeah, that's great. That's good feedback. Try to be a little bit like a science fair and a homebrew computer club then. It's not a pitch for him. It's not a judging thing. Try to make it safe. That's wonderful. Well, it was really cool to get to talk to you and to unpack all the pieces. You have a very ambitious product and project. It's pretty cool.
Thank you.
And someday we'll all be talking to our dogs.
Yes, that's the aim by the end of this year.
So awesome. Thanks.
Okay.